All right, let's work on lesson 11E, which is about identifying properties that are used in solving equations. We've been talking about simplifying expressions, but we also apply these properties when we solve equations also. So in number one, we're talking about Kiera. One of the steps Kiera used, one of the steps she used to solve an equation is shown below. So here's the equation, and notice she took the -5, the +5, I'm sorry, the -5, and the +3x, and she switched the order here. Now, you can do that with addition only, so I always like to think of this as adding addition of a negative. Then you can actually use the commutative property, move the 3x here, and the -5 over here, which is the same as subtracting 5. I usually write plus -5. Either way, you get the like terms by themselves. But the question is asking, in this step to solve the equation, which property allows her to do that? Which property justifies this procedure? When can you switch order? Well, that's the commutative property. So that would be B. Number two. Ray subtracts the same number to each side of the equation. She correctly says that the equation is still balanced, as long as you do the same thing on one side as you do to the other. Well, that's not the commutative property. That means you can change the order. It's not distributive. It's not additive inverse. That's the same as adding opposites, or multiplying by adding opposites. So it must be the subtraction property of equality, which is something you should have learned back in 7th, 8th grade, and then in Algebra 1. There's also the addition property of equality. There's multiplication property of equality. And there's also the division property of equality. As long as you do the same thing to both sides of an equation, it'll be balanced. All right, number three. One of the steps Ivy used to simplify an expression is shown below. So the x here is a times. So it's 7 times 25 in parentheses times 22. Then on the other side, what happened was, I'll write it down below. The numbers are all being multiplied, but notice the grouping changed. What property justifies that either way they'll be equal to each other? The value will stay the same. And that would be the associative property. When you're talking about grouping, changing the grouping, it's still the same answer. That's the associative property. Number four, which equation shows the commutative property of addition? So look carefully at A. That would be the identity property of addition. So we don't want that. In B, A times the sum of 36 and 39. Here you have A times 36 and A times 39. That would be the distributive property, so we don't want that. A plus 36, change the order, 36 plus A, that's the commutative property. So C is correct. Number five, last one we'll go over. Which property does the following equation show? So we look at this equation. 34 times, and then in parentheses, K times M. And the other side is 34 times K in parentheses, then times M. The only thing that's different about them, the order stayed the same, but the grouping changed. And that's allowed using the associative property of multiplication. Hey, keep in mind, you can go back to the notes that we had talked about. They had the properties listed in there. So keep that in mind when you are working, all right? Take a look at those if you need to. All righty, good luck.